We like to measure the universe as if it fits inside a ruler. Kilometers, miles, light years, neat units that make distance feel tame, measurable, almost domestic. Yet the cosmos is too large for the comfort of familiar numbers. At some point, scale becomes absurd and language fails. We need new units, stranger ones, born not from convenience, but from survival. The parsec is exactly that, a measurement that feels like a riddle, a distance that seems to make no sense until suddenly it becomes the only thing that does. 1 parsec is 3.26 light years. Not 3, not 4. A number too specific to feel cosmic, too unwieldy to live in casual speech, too strange to belong in human imagination. And yet, astronomers use it naturally. The parsec doesn't exist to please the brain. It exists to satisfy the sky. Imagine measuring something so large that light itself becomes a ruler. Kilometers dissolve, miles collapse. Even light years start to feel small. Stars drift regardless of our definitions. But we measure so we do not drown in distance. The parsec was not invented to describe distance. It was born to describe parallax, the tiny shift of stars caused by Earth's orbit. A unit born from geometry, not imagination. 1 astronomical unit, Earth to Sun. A star shifting by 1 arcsecond when our planet moves from one side of its orbit to the other. That distance is 1 parsec. Not intuitive, not poetic, but precise. A parsec is not about length. It is about perspective. It is distance defined by motion. The universe reveals itself not through stillness, but through change. Stars shift. We move. Geometry sings. And so the parsec survives because nothing else holds the sky so still. When astronomers look at galaxies, they do not ask how many light years. They ask how many kiloparsecs, megaparsecs. Because beyond a certain scale, distance becomes structure. Light years tell time. Parsecs describe space. We do not measure the universe. We watch it shift. A parsec is proof that the cosmos is alive. Distance becomes strange when numbers outgrow comprehension. A kilometer means something. 1,000,000 kilometers is harder to hold, but still shaped by imagination. Beyond that, scale becomes vapor. Space stretches into a realm where ordinary units crumble, and the mind follows. The parsec was born in that emptiness, not from creativity, but from necessity. A tool forged to measure what cannot be walked, sailed, flown, or circled. A distance measured not by moving toward a star, but by watching how it shifts when we move around the sun. Parallax, the key. The gentle wobble of a star against the background sky, invisible to the naked eye, yet mathematically perfect. As Earth orbits the sun, a nearby star appears to slide slightly back and forth. 1 arcsecond, 1 tiny corner of a circle, 1 3,600th of a degree. Almost nothing, but enough. If a star shifts by 1 arcsecond across 6 months of Earth's orbit, its distance is 1 parsec. Simple geometry, built from triangles of cosmic scale. Not a poetic number, but a functional one. The universe does not bend to human intuition. We bend our units to suit the universe. That is why the parsec feels alien. It is not shaped for speech. It is shaped for starlight. Early astronomers struggled not with distance, but with perspective. How far is Polaris? How wide is Orion? Not in miles, but in angle. The night sky is a map drawn in shifting positions, not linear stretches. Parsec adapts to that logic. It measures space the way the cosmos reveals it, through motion. A nearby star moves more, a distant one less. Parallax is the universe speaking softly, and the parsec is how we listen. Astronomers rarely talk in single parsecs. The galaxy is too large. Instead, kiloparsecs, megaparsecs, clusters, filaments, Voids, 100,000 parsecs across the Milky Way, tens of millions between galaxies. Distances so vast they no longer describe where something is, only how impossible it is to reach. We do not travel parsecs. We observe them. Light takes years to cross them. Gravity shapes them. Time dissolves inside them. They are not pathways, but separations. Oceans of emptiness where galaxies float like islands. A parsec is more than distance. It is the space between truths, the silence between stars. The number exists because humans required a unit that could survive cosmic scale. The meter was too small, the kilometer too timid. Even the light year speaks in time, not geometry. But astronomy is geometry. Angles, triangles, shifting arcs across black sky. The parsec is its natural language. And though the word sounds like fiction, as if born from science fiction script rather than observatory dome, it is mathematically grounded, precise, purposeful. A star's distance is not guesswork. It is a triangle measured through time. 1 arc-second, 1 orbit, 1 parsec. Perhaps the strangeness of this unit is not flaw, but feature. It reminds us that the universe is not scaled to human comfort. It is scaled to itself. We adapt or we misunderstand. The parsec exists because reality demanded a tool we did not have, and so we invented one. We have not yet reached the heart of why it matters, but we are closer than when we began. To understand why the parsec matters, we must first accept that the universe refuses to be measured simply. Nothing in space exists at a scale we evolved to perceive. Our eyes were shaped to see predators across a field, not galaxies across a void. The brain understands a kilometer. It tolerates a million. It collapses at a trillion. Beyond that, distance dissolves into abstraction, unless we anchor it to motion. Parallax became that anchor, not a metaphor, but a measurable shift. A star is never still. Neither are we. As Earth moves through its orbit, the closest stars wobble, tiny as heartbeat, against the backdrop of infinity. This wobble is parallax, and the parsec is the distance at which that wobble becomes exactly 1 arc-second. It is not a number learned, it is a number revealed. Imagine the sky as a sphere around us. Slightly nearer stars tilt, slide, shift. Farther ones freeze. We are measuring motion with geometry, not distance with intuition. Light years speak of travel. Parsecs speak of placement. When astronomers map the Milky Way, they do so in parsecs. When they measure the galactic center, they do so in kiloparsecs. The core sits around 8. The disk stretches to 15. Beyond, satellite galaxies like the Magellanic Clouds drift tens of kiloparsecs farther. And between galaxies, megaparsecs, oceans of nothing punctuated by islands of light. A megaparsec is 3 million light years. A gigaparsec is 1 billion. The words grow stranger as distance grows real. Why use parsecs instead of light years? Because a light year measures time, how long it takes light to travel. But distance in astronomy is rarely about time. It is about geometry, the structure of space, the shape of the sky. And geometry speaks in angles. A parsec aligns with parallax, geometry, placement. Distances become not just big, they become meaningful. The unit tells us how we know what we know. To measure, we do not reach outward. We watch from where we stand. We look again 6 months later. We trace a triangle between Earth, Sun, and star. The cosmos reveals itself by shifting. The parsec is our response to that revelation. Perhaps this is the most poetic thing about a unit that sounds unpoetic. It is born not from distance, but from movement. The universe is dynamic, and our measurement reflects that motion. We know where we are by watching how the stars dance. In this, the parsec becomes more than a number. It becomes a philosophy of scale. It reminds us that we are orbiting, drifting, falling through space. Our reference frame is not fixed. Perspective defines reality. Motion defines distance. Parallax defines placement. The universe is not still enough to be measured statically. We measure not the stars, but our shifting relationship to them. And yet, the parsec carries a quiet humility. It admits that we cannot touch the stars, we watch them move instead. It admits that we are small, that scale cannot belong to us, that we borrow units from geometry because imagination is too fragile. Still, there is beauty in that fragility, in the idea that distance is not wall, but language, that stars speak in arcs and angles, that we listen with triangles. The parsec may seem strange only because it tells truth without apology. The universe is large, too large for comfort, just right for wonder. Scale reshapes meaning. At human size, distance is simple. A road, a river, a horizon. But stretch that scale 1,000 times, 1,000,000 times, 1,000,000,000, and language fractures. Miles become useless, kilometers laughably small. Even light years, poetic as they are, measure time more than space. The universe demands a unit built for motion, for angle, for perspective. The parsec exists because the cosmos is not still. We must linger a moment with parallax to understand why. Picture Earth in its orbit, 500 million kilometers from where it stood 6 months before. A nearby star shifts ever so slightly, like dust drifting across a window. 1 arc second, an angle so small it could hide behind a snowflake. Yet that shift contains everything. It gives us distance without touching, without traveling. We measure by watching how the universe changes as we move. This is why the parsec feels strange, because it is not a scale invented for walking or flying. It is a scale invented for observation. The unit does not belong to humans. It belongs to geometry. A parsec is a triangle written in starlight. And triangles, not imagination, map the cosmos. When astronomers chart the structure of the Milky Way, they speak in parsecs. The sun drifts about 8 kiloparsecs from the galactic center. The starry disk extends nearly 15. The thick disk, halo, globular clusters, structures woven in units of parallax, not kilometers. Because galaxies are not distances, they are arrangements, shapes, relationships between stars. Light years tell how long light travels. Parsecs tell where stars truly are. The difference is subtle but profound. Time is motion forward. Geometry is motion sideways. To know the universe, we need both. And the deeper we look, the more parsecs multiply. Andromeda sits about 780 kiloparsecs away. The Virgo cluster is roughly 15 megaparsecs distant. The Laniakea supercluster spans close to 100 megaparsecs. Beyond that lie filaments, voids, and walls of galaxies stretching through the cosmic web. A gigaparsec becomes a reasonable measurement. Space is not just large, it is structured in unimaginable scales. Yet a question lingers beneath all this measurement. Why should we care? Why learn a unit that feels unnatural? Why hold a number most people never meet beyond textbooks and fiction? Because within this unit lies something quietly profound. The parsec reminds us that knowledge grows not from comfort, but from adaptation. We did not choose this unit to sound scientific. We built it because the universe required it. Because light shifted in ways miles could not contain. Because stars speak in angles, not kilometers. We moved our planet around the sun. The sky moved with us. And from that motion, meaning emerged. If we could see parallax with naked eyes, perhaps the parsec would feel familiar. But we cannot. It reveals itself only to instruments, to patience, to thought. It is a unit for those willing to watch for years, to track microscopic motion of stars across cosmic backdrop. The Parsec rewards commitment. It is the language of those who stare into darkness long enough to notice it breathe. Think of this. When you look up at night, the stars seem fixed, eternal. But give them time, decades, centuries, millennia, and they drift like dust on water. Parallax is the subtle tremble of universe proving it is alive. The parsec is how we measure that tremble. In this way, the parsec becomes intimate, a reminder that we are not outside the cosmos. We are inside its motion. We orbit. We drift. We fall around a star, falling around a galaxy, falling through expanding space. Distance is not fixed to us. We define it through relationship. Perhaps that is what makes the parsec most beautiful. It acknowledges that knowledge comes from movement. Understanding grows with perspective. The universe is measured not by how fast light travels, but by how much everything shifts when we move through it. 1 arcsecond is tiny, 1 parsec is enormous. Yet both are parts of the same truth. To know the stars, we must watch them change. We are only beginning. To see why the parsec is so strange and yet so perfect, we must step into the universe the way astronomers do. Not with intuition, but with angle and patience. Distance in space is not a line between 2 points. It is a shifting geometry between Earth, Sun, and star. The universe reveals itself slowly, by motion so small it takes years to notice. The parsec exists for those who watch long enough. At its core, the parsec is a witness of drift. The Earth travels around the Sun. A nearby star shifts slightly against the deep background. That tiny arc, that trembling point of light, that is the key. Parallax. The universe does not tell us how far away a star is. It tells us how much it moves when we move. Distance becomes a relationship, not a number. 1 arcsecond shift means 1 parsec. If the shift is half an arcsecond, the star is 2 parsecs away. If only a quarter, then 4 parsecs. A puzzle that reveals itself only when observed over months, years, lifetimes. Understanding in astronomy is earned, not given. And because the universe is vast, parsecs stretch immediately into thousands, tens of thousands, millions. We do not see stars, we see clusters. We do not see clusters, we see arms of galaxies. We do not see galaxies, we see filaments of cosmic web stretching across megaparsecs like strands of silk holding reality together. Look at our own galaxy. The Milky Way's diameter is about 30 kiloparsecs, roughly 100,000 light years. Massive, rotating, full of stars born and dead long before Earth existed. Beyond us lies Andromeda, 780 kiloparsecs distant, falling toward us through space. The 2 galaxies will collide in 4 billion years. On that scale, only parsecs make sense, because the parsec is not just a number, it is a map, a way to draw the universe without drowning in zeros. When scientists describe the size of galaxy clusters, they use megaparsecs. The Virgo cluster spans more than 10 mpc. The Laniakea supercluster, our home, stretches more than 100 mpc. Beyond that are enormous voids, hundreds of megaparsecs across, empty like breath between stars. Distances so large they no longer describe travel. They describe structure. Light years tell a story of time. Parsecs tell a story of shape. And here lies the beauty of this strange unit. It forces us to think differently. We stop seeing the universe as something we could cross. We see it as something we can understand only from within. We orbit. The sky shifts. The movement of stars becomes a language. Parsecs become sentences written in black space. Many ask, why not replace parsecs with light years? Why keep a unit so unintuitive? But intuition was never the goal. The parsec was born from measurement itself. To remove it would be to remove the technique, the ability to calculate distance from parallax with clarity. A light year is result. A parsec is method. It is the difference between knowing the answer and knowing how you found it. Perhaps that is why the parsec feels alive, because it grows from process. It is geometry in motion. It reminds us that we exist inside a system of orbits and shifts, that nothing in the sky is fixed, that to understand distance, we must accept movement. And in that acceptance, the cosmos opens. To feel the parsec rather than merely define it, we must follow the path of light itself. A beam leaving a nearby star travels years through silence, through cold, through nothingness so vast it dwarfs imagination. It arrives to us faint, ancient, and slightly misplaced. Not because it moved, but because we did. That displacement is parallax. The parsec is its translation into meaning. In this way, the parsec is not arbitrary. It is born from geometry older than memory. A triangle between Earth, Sun, and star, drawn across billions of kilometers, too large to hold in thought. Yet the angle, 1 arc-second, small enough to hide behind dust. The cosmos demands humility, distance revealed through near-invisible motion. When you hear astronomers speak of 2 stars separated by 5 parsecs, what they mean is this: their parallax is too small to see without patience. They whisper across space in tiny angles. A parsec is that whisper amplified. Most stars visible to naked eye lie within a few hundred parsecs. Alpha Centauri, 1.34 parsecs. Sirius, 2.6. These are close neighbors in cosmic terms, yet unimaginably far for human travel. Distance collapses intuition. Language must stretch beyond sense. And so parsecs scale upward. Nebulae, tens of parsecs across. Stellar streams, hundreds. The Orion Arm, thousands. Galactic clusters, millions. Superclusters, hundreds of millions. A parsec becomes the grain. A megaparsec becomes the canvas. A gigaparsec becomes the cosmos. The larger the scale, the more natural the unit becomes. Strange at first, it settles into mind like a stone in the water. Weighted, appropriate, true. We stand inside a galaxy roughly 30 kiloparsecs wide. We orbit at 8. We drift through an interstellar medium thin as ghost breath, yet capable of birthing suns. Our galaxy moves toward Andromeda at 110 kilometers per second, a collision written across 4.5 billion years. On this timescale, only megaparsecs speak clearly. A parsec is not about comfort, it is about clarity. It exists because light years blur meaning at scale. The universe is too vast to map in units shaped for footsteps or engines. Light years measure travel. Parsecs measure geometry, the shape of existence itself. To see the universe as astronomers do, we must let go of human proportions. A kilometer is human. A light year is storytelling. A parsec is structural truth. And structure is everything. When galaxies form, they do not consider kilometers. They spiral in parsecs. Star nurseries stretch across them. Black holes anchor them. Globular clusters orbit in halos thousands of parsecs deep. Light bounces between stars like seeds in wind tunnels of dark matter. The cosmos measures itself. We only learn to follow. Perhaps that is the quiet beauty of the parsec. It is cosmic scale expressed through human patience. To understand it, we wait months, years, decades, letting the stars move enough for truth to appear. The parsec rewards those who watch slowly. It is a unit built for meditation. Distance becomes not a number, but a relationship unfolding through motion. And still, we have not reached the strangest part. The strangest truth about the parsec is this. It was not created to measure distance at all. It was created to measure the absence of motion. Parallax measures how much a star shifts when Earth moves. But some stars do not shift enough to see, even over years. For them, distance becomes immeasurable through angles alone, fading into numbers too large for parallax to resolve. A parsec is not only a tool for knowing, it is also a boundary of what can be known directly. Beyond a few thousand parsecs, parallax becomes nearly silent. The wobble disappears into stillness, drowned inside precision of instruments. We know a star is far away when we cannot detect its shift at all. Distance becomes darkness, known only by the failure of motion. And so astronomers layer methods, spectral lines, standard candles, Cepheid variables breathing like cosmic hearts, supernovae bright enough to illuminate millions of parsecs at once. Each distance ladder steps beyond the reach of parallax, but it begins with it. A parsec is the first rung on the ladder that reaches galaxies. Without the parsec, every larger scale collapses. Astronomy is not built on light years, but on parallax, on the tiniest shift of stars we can see. Imagine a triangle so vast, one corner sits at Earth in January, another in July, and the third hangs inside a star thousands of years old. That triangle is reality. The parsec is its measure. When we speak of 10 parsecs, we speak of 10 angles. When we speak of 1,000, we speak of 1,000 silent stars, barely moving across centuries. To measure scale of galaxies, we begin with whispers of nearby suns. And then comes the deeper poetry. A parsec is not a number we invented. It is a number the universe revealed. Parallax exists whether humans see it or not. Stars shift whether we measure them or not. The parsec is simply the moment we understood. It is cosmic geometry translated into language. But why does this matter? Because to understand our place in the universe, we must sense scale not as size, but as structure. The Milky Way is not only wide, it is arranged. Spiral arms, stellar nurseries, orbits within orbits within orbits. Everything in space moves. Nothing stays. And still, the parsec holds. 5 parsecs, a small neighborhood of stars. 50, regions of gas and dust shaping sunlight. 500, globular clusters dense with ancient suns. 5,000, the radius of spiral arms. 50,000, the width of our galaxy. 5 million, the space between galaxies. The pattern becomes visible only when measured in parsecs. Kilometers break. Light years blur. Parsecs reveal. And somewhere in this understanding, the unit stops being strange. It becomes natural, as though the cosmos was waiting for us to invent a word for how it breathes. We are no longer asking what a parsec is. We are beginning to understand why it exists. Understanding the parsec is an almost philosophical act. It forces us to accept that the universe is not measured by human scale or memory, but by movement we are too small to notice. The sky above us, which looks still and fixed, is shifting every moment. Every star is slowly walking across the cosmos, and every orbit we complete around the sun repositions us in that grand landscape. The parsec is the quiet proof of that motion, the geometry of our changing perspective. Imagine the night sky as a painting that is alive, not frozen, not static, but flowing like a tide of light. Over centuries, the constellations distort. Orion stretches. Cassiopeia cracks open. Stars drift like dust in sunlight. Their movements are too slow for a single lifetime to perceive, but real enough to define the architecture of space around us. Parallax is the subtle heartbeat of that living map. and the parsec is its translation into number. A unit built not from human need, but from cosmic truth. And yet, the strangest beauty is that we use it even though we cannot feel it. When astronomers say a star lies 120 parsecs away, they speak of an angle so small that human eyes could never register it, not even across thousands of years. Our species is too young, our lives too short, our senses too coarse. But mathematics extends our perception. We cannot see 1 arcsecond, but we can measure it. We cannot travel a parsec, but we can know it. In that, the parsec becomes a triumph of intellect over scale. It reminds us that knowledge grows where experience cannot reach. Even more curious, the parsec has shape. It is not simply 3.26 light years. It is the distance at which parallax becomes 1 arcsecond. Change the angle, and the universe rearranges itself. A star shifting by half an arcsecond is 2 parsecs away. A quarter, 4. Perspective stretches reality like elastic. Distance and perception are woven into one thread. Learning the parsec is learning to see differently. We begin to sense the Milky Way not as a flat disk of glittering points, but as a structure vast enough that kilometers are meaningless. A star-forming region may span 20 parsecs, a nebula, 50, a molecular cloud, hundreds. Stellar streams wind across thousands. The central bar of our galaxy stretches thousands more. Then parsecs become kiloparsecs, and the galaxy becomes architecture. 8 kiloparsecs to the galactic core, 15 across the spiral arms, 30 from edge to edge. A unit once strange becomes natural at scale. And beyond our galaxy, megaparsecs. Tens of them, hundreds. A void between galaxies becomes a measurement. Filaments connecting clusters become cartography. Parsec on parsec, space expands into shapes too vast to carry. Light years feel emotional, beautiful, poetic. But parsecs are structural. They tell us how space fits together. They are not about travel. They are about truth. The parsec exists because the universe will not wait for us to understand it. Stars move whether we watch them or not. The cosmos expands whether we count or not. Parallax happens without permission. The parsec is simply the language we built to listen. And the more we listen, the more the universe speaks. The farther we move into the idea of the parsec, the more it becomes clear that astronomy does not measure distance. It measures perspective. A light year tells us how long a message travels. A parsec tells us where the source is positioned in 3-dimensional space. One unit speaks of time, the other speaks of structure. Neither is wrong. But only one reveals the architecture of the universe. To grasp this, imagine standing on opposite sides of Earth's orbit. January and July. The sun now lies 500 million kilometers behind us compared to 6 months ago. We look at the same star twice, from 2 positions far apart, and the star appears in 2 different places in the sky. Not because it moved, because we did. That shift, that microscopic slide across darkness, is parallax. The parsec is the scale on which that shift becomes just 1 arcsecond. It is elegant in the way physics rarely is. No arbitrary constants, no invented scale. Only motion, angle, distance, 3 points forming a triangle large enough to map galaxies. In this light, the parsec becomes a window rather than a ruler. Through it, we see the universe as dynamic, not static. Stars wander, clusters drift, galaxies fall toward each other like slow snowflakes through gravity. On planetary timescales, the motion is invisible, but across centuries, it becomes undeniable. The parsec measures that invisibility and gives it form. Some might ask why this matters to anyone outside astrophysics. What value is there in parsing parallax? Why care how astronomers mark distance no one will ever travel? But the parsec is not only a tool of measurement, it is a reminder that reality exists on scales beyond emotion or familiarity. We cannot cross a parsec, but we can comprehend it. Science extends consciousness beyond anatomy. When you look up at Orion, those bright stars appear close together, but their distances differ by hundreds of parsecs. Betelgeuse, around 150. Rigel, around 260. Bellatrix, 75. Mintaka, 300. A constellation becomes not picture, but projection. Light drawn from wildly different depths of space. Without parsecs, Orion is an image. With parsecs, it is structure. Suddenly, the heavens are no longer flat. They are layered like ocean thermoclines, depth hidden beneath reflection. And beyond constellations lies the shape of the galaxy itself. The Milky Way is not a band of stars. It is a disk tens of kiloparsecs wide. Spiral arms curve across parsec after parsec, like strokes of light in slow rotation. The galactic core glows 8 kiloparsecs away. The halo extends far beyond. We are inside its depth, unable to step outside and look back. The parsec allows us to reverse perspectives, as though we could hold the galaxy in our hands and measure its bones. The deeper one travels into this unit, the stranger it becomes. A megaparsec spans millions of parsecs, distances large enough that clusters of galaxies become points. The Virgo cluster stretches 15 megaparsecs. The filament of Perseus Pegasus spans hundreds. Superclusters weave across the cosmos like neural pathways. At this scale, light years collapse under the weight of numbers. Only parsecs remain coherent. Because the parsec is not scale, it is geometry. It grows when the universe grows. And there is a quiet poetry in that. The stars speak in angles too small for flesh to see, yet we measure them. We find meaning in the smallest tremble of their light. Parsec is proof that human thought can stretch beyond human boundary. Even if our bodies never leave Earth, our perception has already crossed gigaparsecs. Perhaps that is the true reason the parsec exists. Not merely to quantify distance, but to expand imagination through precision. The further we go, the more the parsec begins to feel less like a measurement and more like a key. It unlocks the third dimension of the sky. Without it, the universe is a flat tapestry, brilliant, beautiful, but depthless. With it, the cosmos becomes architecture, volume, space you could fall through forever. Stand under the night sky, look up. Every star seems pinned to a single surface. A dome, a ceiling. But that illusion is born from the limits of human perception. Distance collapses into pattern. Brightness becomes proximity. The mind, untrained, believes everything is close, simply because it is visible. The parsec teaches us to see differently. We learn that some stars burn near and others far beyond imagining. We learn that constellations are accidents of alignment, projections, not neighborhoods. Orion is not a figure standing in the dark. It is a coincidence. Points of light separated by tens, hundreds of parsecs, connected only by perspective. The parsec unthreads that illusion, stitch by stitch. And once depth appears, the universe expands in every direction at once. Not outward, inward. We begin to see the space between stars, the voids, the rivers of dust, the glowing nebulae where new stars are born. A single parsec across a stellar nursery can hold thousands of young suns wrapped in gas like embryos of fire. A molecular cloud may span dozens of parsecs, heavy with hydrogen, trembling on edge of collapse. We start to feel scale not as number, but as environment. 1 parsec might hold 3 stars. 10 parsecs might hold a cluster. 100 parsecs might carve a spiral arm. 1,000 parsecs might define a galactic orbit. This is why astronomers stopped thinking in kilometers long ago. They were too small to describe the landscape of creation. Then, as the scale widens further, parsecs stack into kiloparsecs and megaparsecs. We map the Milky Way's width as 30 kiloparsecs. We measure the distance to Andromeda as 780. We locate the edge of the local group at around 1.5 megaparsecs. We begin to see not stars, but societies of galaxies, linked like cities across black oceans. At 50 megaparsecs, cosmic structure becomes visible. Walls and filaments, superclusters like continents, voids like seas. The cosmic web emerges, and space stops looking empty. It looks organized, patterned, alive. And yet, every structure, every cluster, every filament, every node of galaxies rests on the first rung of parallax measurement. The parsec is the seed from which cosmic cartography grows. It is astonishing, really. A unit born from 1 arcsecond, one tiny tilt of starlight, becomes the framework for mapping the structure of everything. The largest formations ever known, spanning hundreds of millions of parsecs, arise from the smallest measurable motion in the sky. Humanity did not build this logic. The universe offered it. We simply learned to listen. In this quiet realization, the parsec stops feeling absurd. It begins to make sense in a way that light years cannot, because it is built not from travel, but from perspective. It is not a path, it is a way of seeing. And once you see depth, you can never return to the flat sky again. Everything returns to perspective. The parsec is not only a unit, it is a doorway. It does not describe the sky as a map, but as a shifting organism. A light year tells us how far light travels in time. But a parsec tells us how the universe rearranges when we move. And movement is the only truth space cannot hide. Years measure memory. Parsecs measure experience. Once this difference settles into the mind, something subtle changes in how we perceive distance. A kilometer becomes a footstep. A light year becomes a message. But a parsec becomes a landscape, wide enough to hold star nurseries, old enough to carry stellar fossils, deep enough to contain the time it takes for atoms to gather themselves into suns. When astronomers peer into molecular clouds, thousands of parsecs wide, they are not counting distance. They are watching gravity stitch light from darkness. Regions like Carina, Taurus, Perseus, each a theater of collapse and ignition. A parsec becomes a womb where stars gestate for millions of years. And then scale stretches further. A single spiral arm of the Milky Way may span 10,000 parsecs, braided with gas and dust like cosmic rivers. We orbit the galactic center at 8 kiloparsecs. Moving through space we will never see with naked eyes, yet chart with impeccable clarity. Not because we travel, but because we watch. Parallax is the heartbeat. The parsec is the rhythm. Even now, modern telescopes refine this measurement. Gaia, scanning 1 billion stars, measures parallax with precision so sharp it can detect angles smaller than 1/10,000th of an arcsecond. Distances once unknown now speak clearly. The Milky Way, once a blur of stars, becomes depth, structure, architecture. Every parsec pins one more point in the web. Without parsecs, the galaxy would remain two-dimensional, beautiful but deceptive. And this leads us to the quiet answer hidden in the question, why does the parsec exist? Not because kilometers failed, not because light years confused, but because the universe demanded a unit tied to motion, not imagination. The parsec exists because perspective exists. We are not stationary observers. We orbit a star that orbits a galaxy that drifts through expanding space. To measure distance in a universe where nothing is still, we must measure by movement. A parsec is distance written in the language of motion. It is not a number, it is a method. a technique, a philosophy, kairos, not chronos, geometry, not story. When a star sits 1 parsec away, it means we can see the universe shift around it. When it sits 10 parsecs away, that shift shrinks but remains visible with patience. When it lies 1,000 parsecs distant, its parallax is silence. A silence we fill with standard candles and redshift, but a silence rooted in the first arcsecond. In this sense, a parsec is the foundation upon which the cosmic distance ladder stands. Without the first rung, no higher step could exist. Light years speak across time. Parsecs define the stage on which that time unfolds. They answer the question, where is everything, truly? Not by guess, but by geometry. And so the parsec does something profound. It makes the universe three-dimensional. It breaks the dome of night and reveals the cathedral of space. Once we see with parsecs, we never look at the sky the same again. The closer we move to understanding the parsec, the clearer it becomes that it is not a unit built for people. It is a unit built for the universe itself. We created meters to measure our world. We created kilometers to stretch beyond it. We created light years to speak of travel across time. But the parsec exists because the cosmos demanded a measurement that reflected motion rather than memory. In astronomy, nothing stands still. Stars wander through the galaxy like leaves carried by invisible currents. Clusters drift, spiral arms twist, nebulae collapse into light. Even the universe itself expands, steadily, quietly, pulling galaxies apart like ink diluted in water. On such a stage, distance is not fixed. It is relative to where we stand, to where we move, to the angle at which light arrives. The parsec was born because geometry could see what intuition could not. When a star shifts by 1 arcsecond across half an orbit of Earth, it resides 1 parsec away. If it shifts by half that amount, the distance doubles. If the shift shrinks further, the gulf widens exponentially. A tiny reduction in angle translates into a vast expansion in space. 1 second of arc, 1 parsec. A quarter second, 4. 1/20th, 20. Larger distances compress parallax into silence, and yet the relationship remains. The universe speaks through angles. We answer with parsecs. In this way, the parsec does not merely measure distance. It reveals scale. It exposes the true depth of the night sky. A star may appear bright, but lie 20 parsecs away. Another dim star may stand only 4. A cluster blooming with new suns may stretch across 30. A molecular cloud, 100. A spiral arm, thousands. A galaxy, tens of thousands. Clusters of galaxies, millions. Superclusters, hundreds of millions. And somewhere beyond the reach of light itself, billions. At these scales, kilometers become noise. Light years become poetry. But parsecs become clarity, structure, a map that does not dissolve under magnitude. The universe stops being confusing. It becomes dimensional. We navigate not by distance, but by motion. It is strange how this simple unit carries such weight. To speak of 1 parsec is to speak of a triangle between sun, earth, and star. To speak of 1 megaparsec is to speak of the space separating galaxies, the magnetic threads of cosmic web, the great architecture's gravity built across billions of years. Parallax, the smallest wobble, becomes the first brushstroke on the canvas of everything. Without the parsec, the night sky would remain a picture. With it, it becomes a landscape. And herein lies the quiet secret. The parsec exists so the universe may have depth. It exists so the sky may be more than a ceiling. It exists so we can step from 2 dimensions into 3. So constellations become structures. So illusion becomes range. We do not measure stars. We measure how we move through their light. And in that motion, we find truth. Not distance as humans know it, but distance as the cosmos tells it. The closer we draw to the heart of the Parsec, the more it becomes a mirror, reflecting not just distance, but our relationship with the universe. We began with confusion, a strange unit, unfamiliar, inconvenient. Now it begins to feel like truth. Not elegant like a light year, not intuitive like a kilometer, but honest. The Parsec reveals the universe as it is, vast, layered, shifting beneath our feet. We learn to measure space not by how far light travels, but by how the stars move when we move. A parsec is not about the stars themselves. It is about our orbit around the sun, our changing point of view. To measure in parsecs is to admit we are part of the cosmos, not observers outside it. Earth's orbit becomes ruler. Parallax becomes language. Motion becomes clarity. It is a subtle revelation. Distance is not static. It is relational. A star's position is never fixed unless we are fixed. And we never are. Even standing still on Earth, we hurtle through space at thousands of kilometers per second. The sun carries us around the galactic center. The galaxy drifts through the local group. The local group falls toward Virgo. Everything is moving, always. The parsec exists because of that motion. At small scales, parallax is measurable. A star 6 parsecs away shifts by 1/6 of an arcsecond. One at 100 parsecs barely shifts at all. One at 1,000 becomes silent. Yet silence itself is information. If the wobble cannot be seen, the star must lie far beyond. And so the parsec reveals distance through presence and through absence, through motion felt and motion lost in stillness. Beyond the reach of parallax, we stretch the ladder of measurement further. Cepheids pulsate across space like stellar clocks. Supernovae flash like cosmological beacons. Redshift stretches the wavelengths of distant galaxies like fabric pulled over centuries. But even these advanced methods trace back to the first rung, the parsec, the foundation, the origin of scale. If we did not know the parsec, we could not trust the megaparsec. If we could not trust the megaparsec, the universe would narrow into uncertainty. The cosmic web would unravel into abstraction. Stars would lie without depth. Galaxies would flatten. Distance would collapse. In this realization, the parsec becomes almost poetic, though born from geometry. It teaches patience. It honors time. We must wait months to see a star shift, years to refine, decades for accuracy. The parsec rewards stillness and persistence. It is a measurement that asks not for power, but for observation. And this reflects something profound about us. Humans are small, brief, fragile, and yet capable of measuring what the universe hides in angles too small to see. We cannot touch the stars, but we can know them. We cannot cross the void, but we can map it. Knowledge becomes our motion through a universe we may never physically traverse. To think in parsecs is to think with cosmic patience. A single parsec contains stories. Stars forming from collapsing gas, planets gathering like dust in a whirlpool, supernovae scattering heavy elements into future worlds. 10 parsecs reveal stellar neighborhoods. 100 shows galactic structure. 1,000 unveils the arms of the Milky Way. 1,000,000 parsecs becomes a bridge between galaxies. 100 million trace the filaments of the cosmic web. 1 billion outline the bones of the universe. The universe becomes visible not in light years, but in parsecs. And perhaps the true beauty is this: no one can feel a parsec. We cannot walk it, drive it, live long enough to see light cross it. Yet we understand it. We speak it. We navigate reality with it. The parsec transforms human thought into something larger than the human body. It allows the small to measure the infinite. In the stillness of night, when the stars seem motionless and eternal, the parsec reminds us that nothing holds its place forever. Not stars, not galaxies, not even the universe itself. Everything drifts. Everything shifts. Parallax whispers this truth through angles too faint to witness, but clear enough to measure. The parsec exists because the universe moves, and because we learn to follow. The parsec exists because the universe refuses to be small. It exists because space is not empty, but layered, dimensional, vast beyond metaphor. We spent centuries staring at the sky as if it were painted onto a dome, as if the stars were lanterns hung at equal distance. Only when we learned to measure parallax did the sky fall open, revealing depth like an ocean beneath moonlight. To understand the parsec is to understand that reality is not flat. And now, at the end of this journey, we can return to the simple question that began it. Parsec. Странное расстояние, которое не имеет смысла. Parsec. Зачем он существует? It exists because the cosmos speaks in angles, because stars drift, because Earth moves, because nothing is still long enough for kilometers to matter. It exists because the universe can only be known through motion. We are not measuring distance. We are measuring change. That is the revelation. A light year tells us how long a story travels. A parsec tells us where the story began. Distance is no longer a line. It is a relationship between moving points inside a moving universe. To measure in parsecs is to acknowledge that nothing stands alone, that perspective is part of truth, that space is geometry, not surface. And so the parsec becomes more than a number. It becomes a worldview. It teaches us that scale is fluid, that meaning is revealed through patience, that truth may be invisible yet measurable to those who wait. Perhaps this is why the unit feels so strange, because it is not built for walking bodies, but for thinking minds. It belongs to a universe too vast for the human frame, yet perfectly suited for the human imagination. A parsec cannot be touched, but it can be understood. It cannot be crossed, but it can be known. Knowledge becomes travel. Perspective becomes distance. The night sky is no longer a ceiling. It is a cathedral. It stretches not outward, but inward, into perception, into geometry, into the space between stars that once looked close, but now stretch across millions of years of light and millions of parsecs of structure. The parsec dissolves illusion. It restores dimension to the universe. And in that restored depth, something awakens. A sense of proportion, a sense of motion, a sense that the cosmos is alive, shifting, breathing through angles and arcs too small to see, but impossible to ignore. One arc second, one orbit, one parsec. Enough to remake the shape of the sky, enough to expand the mind beyond its limits, enough to remind us that we do not stand outside the universe, we move with it. That is why the parsec exists. It does not measure distance, it measures perspective, and perspective is everything.